Good day and welcome back. Today, our topic for discussion is regarding protection release setting for medium voltage bus coupler. So, the bus coupler is located on this part of the 11 kV switchgear at the building B. So far, this will be our 6th video, and so far we have done already 5 videos. This area from here, it's already being posted to our channel. So to have an overview for this power system, our first video has discussed on this first section from this bus coupler here. This bus coupler, it is located on the building F, main 11 kV switchgear at the building F. So that was our first video. The second video that we prepared is regarding the protection relay setting of the relays which has been installed at this point here, the outgoing feeders from building A 11 kV switchgear, and also this point here. This is the feeder which supplies power to our 11 kV switchgear at building F. So on our second video, the settings on this relays from here are also the same settings from our incomers of this 11 kV switchgear from here, from this building F. So that was our second video. Our third video is the relay setting of the bus coupler located in this section from here between 70 BBA and 70 BBB, okay, for the 11 kV switchgear of the building A. Then the fourth video that we have prepared also, by the way, I encourage you guys to watch those previous videos to understand the relay settings that we have calculated earlier for these relays that I have mentioned. So our fourth video has been dedicated to these two incomers here, the same setting, okay, for this building A. Our fifth video, our last video that we posted on our channel, was regarding the relay setting for this cross tie line which is being linked or being connected between the 11 kV switchgear of building A and the 11 kV switchgear of building B, this section. That was our fifth video. Right now, our sixth video on this session, we will be discussing the relay setting for this bus bar, bus tie or bus coupler. So this will be our sixth video out of 8 video that we're going to prepare. Today's session, we'll call this one as protection relay setting calculation for medium voltage bus coupler. So later we're going to discuss, after the 6th video, we're going to prepare also videos regarding the relay setting calculation for this incomer here. This will be our 7th video, and our 8th video, that will be the last video to that has to be prepared, is the relay setting calculation for this incomer also on this bus B side of the 11 kV switchgear. So we'll go back here Now, this as what you have seen in the screen, the overcurrent protection on this bus coupler is only a directional overcurrent protection relay that we have provided here. So we have here the values already for our 67 relay in both directions. So we have this direction going to the left, and we have also these values that is going to the right. By the way, if you are wondering how we got the assignment of our time setting here, you can refer to our video number 1, video number 2, and video number 5, wherein I discussed in the previous videos on how to assign our time setting from here. On this 6th video that we are discussing right now, the time setting which is going to this way, going to the right, is being set at 0.35 seconds, and going to the left is being set at 1.35 seconds. So let's discuss now how we calculated, how we come out these values on what we have here. So this is, we call the bus coupler between 70 BBC bus and 70 BBD bus. So our release being used is F60 from GE and MyCom P143 from Schneider Electric. So our CT ratio is 25:1 ampere, Vardin is 10 VA, and a class 5P20. So our PT ratio is 11,000 is to 110 volts. So our 11 kV minimum line-to-line fault is rated 8,406 ampere. 11 kV minimum line-to-ground fault is 409 ampere. So as you have right now, we will be calculating our these following relays: the 51 relay, the 67 relays here, also the 67N, the relay 59, and relay 27. So let's open again this. Anyway, what is mentioned right now in our bus coupler from here is only directional relay, but we have also calculated if you refer our calculation, we have also calculated the ANSI 51 relay. So let's start on our relay 51. So this relay 51, by the way, is for the first threshold. So for our first threshold, this is being set at 120% of the rated current of the CT. Our CT is being rated as 2,500 multiplied by 120%. So our first threshold current pickup setting is set at 3,000 ampere or 1.2 per unit. We'll just multiply 3,000 by the relay ratio of 1/2,500. This is how we got this 1.2 per unit. So we adopted the our inverse time curve is IEEE very inverse, and our time dial multiplier is being set at 0.40. So how we got this value? By using this equation, and we have the following constants from IEEE standard for A, B, and P, and our first threshold is being set at time 1.35 seconds. So, and our fault current 11 kV minimum line to line is 8,406. That's why we have this information. And our pickup current is 3,000 amperes. So, we also substitute the information from the IEEE standard constants from here. After that, after we calculated the result, the time dial multiplier is 0.40, and we reflected this information from here. This is for the first threshold for our phase overcurrent protection. Our second threshold, we will, on also our third threshold, we will be using directional phase overcurrent protection. So for our second threshold, this being set at 105% of the downstream threshold protection setting at setting, by the way. So our downstream setting is 3,900 amperes. So how we come out this 3,900 ampere? So if we open this, our subject for discussion is this bus coupler, right? This bus coupler. So this 3,900 is taken from the loads, all the total loads on this area from here, on this bus. So this, the total current for this one is total 3,900. So that's our reference how we got the information to have the release setting of 3,900 from here. So multiplying 105% to 3,900, we have here 4,095 ampere, or our second threshold pickup current is being set at 4,100 ampere or 1.64 per unit. The side detection is at the building B on this side from here. The side detection, this is building B on this side from here. Okay, from this building. Then this is being set at 0.35 seconds. Okay, this is on the first direction. On the opposite direction, on our third threshold, we have here assigned also 105% of downstream threshold protection setting, which is 4,750 amperes. So how we got this 4,750 ampere? This information from here, this one, okay, on the other side, on this direction, on this going direction. Earlier on our second threshold is on this direction going to the right. Our third threshold is going on the left direction. So we'll go back here. This 4,750 is taken from this going to the right direction. Okay, so 105% of 4,750 is equal to 4,988 ampere, or we set the pickup current or the third threshold phase overcurrent protection is being set at 5,000 ampere at 2 per unit. So, the side detection is on the 70 BBD01GH01. So, this one. This bus bar from here. Okay. So, on our definite time setting is being rated at 1.35 seconds. So from here, since we are adopting this direction, right? This direction, we set this one at 1.35 seconds. Okay? That is for the overcurrent protection. So, for the review, for the overcurrent protection, we have 3 threshold. The first threshold, we use the time overcurrent protection. On our second and third threshold, we use our directional phase overcurrent protection. For our earth fault protection, we're going to use a directional earth fault protection. So, our first threshold, because you remember we have 2 threshold here. One is when we have at this direction going to this right at 0.35 seconds and going to left at 1.35 seconds. So our first threshold is being set at 12. This first threshold is being set at 12% of the rated current of the city, which is 2,500 ampere times 0.12. That's why we have this 300 ampere. So it's being set for our earth fault protection. The first threshold is being set at 300 ampere at 0.12 per unit. Then time setting is being set at definite time of 0.35 second. Our second threshold is on the opposite direction. This threshold is set at 12.5% of the rated current of the city. So we multiply here 0.125 times 2,500 for the city. That's why our second threshold is being set at 312.5 ampere or 0.125 per unit, with a definite time set at 1.35 seconds. So here our time setting is also the same on our phase overcurrent protection, our time setting for our earth fault protection. So we have done our phase overcurrent and our earth fault overcurrent protection. Now we're going to discuss the voltage protection. So first, our phase over voltage protection or the 59 relay. So this threshold is being set at 115% of the rated voltage. Our voltage here is 11,000 volts. So our threshold for our over voltage is being set at 12,650 volts or at 115 per unit, with a definite time set at 2.25 seconds. Last, our phase under voltage protection is being set at 80% of the rated voltage, which is the 11 kV. That is multiplied by 0.80. So our phase under voltage pickup value is being set at 8,800 volts or 0.80 per unit, with a definite time set at 3.75 seconds. Thanks for watching.